locked on the server, so nobody else can actually go and change those files. And merging was a bit of a pain. So I would actually encourage you to watch Linus Torvalds' talk. Let me just go to YouTube and search for Linus Torvalds' Git talk. This one, the one he gave at Google. It's a good talk that actually gives you the motivation behind the development of Git and why you should use it. So the objective here is, of course, to understand the basic mechanics of Git. And let's get started. So let's say that we are working on a project, and let's say I'm just going to create a directory called let's say hello, right? And this is my project directory. So I am just can you see the text on the terminal? Can someone confirm, please? Is the text font size big enough?
Yes, it is.
Okay, thank you.
Yes, you can see.
Yeah, thank you. So I'm now in my new directory, and I would like this project directory to be version controlled. Git is decentralized, which means you have a complete history of your local changes. And there's something called remote as well. We'll come to that later. So whatever work that you are doing, you can keep track of the changes locally. So the way I would do it is to initialize a project folder, I would just say git init. It says I have a empty Git repository. And if you check with -a hidden option with ls, you'll see there's a .git folder created. So the first thing you should do is add your user details. So I'm just going to quickly add mine so that you can see the commits. Okay, so I added a user. It's like in your INI file. I've created a user section and name and email attributes with the corresponding values. So when you make revisions or commits with using Git, it is basically uses your name and email address. This is a simple configuration that you need to do. And then the way to check that the project is clean, Git shows a clean output, is just check Git status. It says it's on branch master, no commits yet. So let me start by say I want to create a let's say a README file. So if I do ls, there's a README file, and I'm going to just add some content to that. I'm going to save the file. Right now, if I do git status, what does it tell me? It says that it is currently tracking this project folder hello, and it has an untracked file. Okay, there's a new file called README, and it also suggests saying you can add this file to the repository. The repository is the local repository, which is in the .git folder. You generally don't have to go and make changes to the .git folder. So I'm going to git add dot, basically adds everything in the current folder, and I'm going to say git status. It tells me that there's a new file called README, and you can commit it to the local repository using git commit. Give a commit message. I'm just going to say first commit. Okay. I can always use git status to make sure that the git repository is clean. So what has Git done is it has added this README file to the local repository, and you can quickly check with say git-show. This tells me that the I've made this first commit, and I've added a README file, and I've added this text to it. Okay. So you can keep doing commits and making changes continuously. The idea in free labor and open source software development is that you make small changes and you make them often so that you can keep track of history. Now, the fundamental thing about Git is that there are three sort of areas. So let me just go to the presentation. So yeah, just ignore the names. It's done a little bit creatively, just to give you the idea. So you can also have a global Git settings. You can specify the username and email so that your home.con git config will have these settings instead of project level settings. It's also a possibility. And I've just added this GL as an alias for seeing the comments. You'll see it in the output. Right. So basically, what you will see here is that instead of README here, it's just the to my dearest.txt file. So Git has three things that you need to remember. One is the working tree, the index, and the repository. Okay. So what we've done is we created this to my dearest or README file in our example, and then I have made some changes to the file. I've added it. So when I add it, what happens is Git takes the changes in the working tree and it puts it into a staging or index area. So this staging or index area is something like a buffer. Okay, things that you feel that they're ready to be committed to the repository. Okay, so when you're working on a project, you will be working on multiple files, and whenever you feel that your changes are ready, what you do is you add it to the index, and then you make a commit, and you get one SHA-1 commit number, and you can always check git status to take the status of the repository. And again, you can keep adding more files. You can work on the existing files, and the different workflows is what you're going to see next. Okay. Right. Moving along. So let me go back to the terminal. Right. So now I have just one file. Let me say I create a changelog file, and I'm just adding changelog here just to show that I'm making some changes to the file. The git diff command is quite useful to understand the difference between the working tree index and the repository. So if I just do git diff, there's no new change except for the file, and I can do git diff --- cached, which tells me the difference between the tree and the cache, and then you can do git diff. So what are these? Let me show you in the presentation. So it's showing a git-show. Right, so I'm creating a file here, which is changelog file. So this file is in the working tree. Okay, and when you do git diff, it compares the working tree and the index to see if there's any change. But there's nothing in the index, so there is nothing to diff there. And then it compares diff cache between the index and the repository. Now, the head refers to the head of the Git repository, where it points to. And by default, we have what's known as the master branch. So we'll talk about branches later on. And then we have git diff head, which compares the working tree and the head. So we'll go through these different workflows where you understand how to move files between the working tree and index and repository, back to index, back to working tree, and so on. Okay. So the most important thing is diff is a useful tool to see what changes are in index and what changes are going to be committed to the repository. As always, you can check git status, and this tells me there's a new file here. So if I do git status, It tells me I've created a new changelog file. And if you want, you can just add that file and you can commit it to the repository. Now, if I don't want this file, what do I do? Right, I can just do git rm -f changelog, or just do git remove, or just remove changelog. Doesn't matter. It's not being tracked by Git, so you can just remove that file. You can check Git status, and it will still say that the repository is clean. Okay. So this is a case where you've added a new file and you thought it will be useful, but it is not useful. Okay, so then you can just simply delete the file because Git does not know about this file and is not being tracked by Git. Let's take another example where, let me clear this again. This is the case. Let me add this file called version. It's called 1.0. I check git status. Now I'm adding this file from the working tree. The working tree has version. I'm adding it to the index. Right? So I'm here. So I added this file. Here is this name, but it's actually a version file in our demo example. So I'm adding it to the index. And then I can check the output of all the diffs. Right? So I can say git diff -f cached. What does cache say? Now you've added the version file to the cache. It says that this changes, if committed, will be committed to the repository. Right? And then git diff head says these are changes are about to be committed to the repository as well. So you've created a new file called version. You're adding it to the index. Git diff cache says these are the changes that are about to be committed to the repository. And git diff head also says that these changes will be between the working tree and the head. This will be the delta changes that will be about to be committed. So if you don't want this, you can remove using -- cached, right? And check git status. You can do ls first, right? So it's removed from the index. It's still there in the working tree. So when I do, let me quickly show you this, right? So the version file was there in the index. When I removed it, okay, this force removal. In this case, it's still there in the, it's not there in the index, right? It's there in the working tree. And if I don't want, I can just go and remove this one. So this is an example where you add a file to the index staging. You thought it will be useful. It's about to be committed to the repository, but then you realized, oh no, this file is not useful anymore, and you just want to bring it back from the staging to the working tree and just discard it. Okay, so this is a useful case where you move a file from working tree to staging and then bring it back to working tree and then delete it because it's not useful anymore. All right. Let's do, we'll just check git status. So you're always in a clean tree. Let me create another file, maybe authors, and let me add this file. And I'm going to make a git status as a new file. Git does not know about this file. So I'm going to add this file to the index, the staging area. I check git status, says it's a new file. Now I can do git commit and So try to do meaningful commits. Okay. Now if I do git log, it will tell me there are 2 commits. The first one was the first commit, and then we had the authors file. So now there are 2 commits, right? And check git status, we are good. Now suppose, let's say that I made some mistake in the authors file. Okay, this is the most recent commit. I want to undo this commit, but I want to keep the changes in the index. So basically, if you go back to the presentation. Right. So I've created a new file, working tree. I added it to the index or staging area, and then I made a commit. This is what we are, right? We have 2 commits now. And then what I want to do is, I want to undo this latest commit, but I want to keep those changes in the index. Okay. So you see here, this commit, this command git reset -- soft, move the head to the previous head. What it does is, now I have 2 commits. I want to undo the most recent commit, but I want to make changes to those files, and I want to keep them in the index. So what I do is, I do git reset -- soft head previous. So it undoes the most recent commit and keeps the changes in the index, so that I can now make modifications to that. Okay, so let's try this. So I have 2 commits now. So I do git reset -- soft head previous. Okay. If I check git status, I see that the authors file has been, that we created, is now moved from the commit to the index or staging area. So if I now do git log, it will show me only 1 commit, the first commit. What we have done is, we made a recent commit to the local repository. Then we realized, oh, I need to make some changes to that. You could make 1 more commit. You again modify the file, make 1 more commit. Or in this case, it's the most recent commit. So you want to undo the commit, make changes, and commit it back again. So you want to bring the recent commit changes to the working tree, right? And then let's say I add some name here. And then what I need to do is, it says that now if I do git diff, since this authors file has already been tracked by Git in the repository, it knows that the changes that are being done will be available. So again, these are changes in the cache. And so what I can do now is, I can re-add the changes. Right? Now git diff cache will tell me the SK is also added to it. And then I can make a commit. Added name. So now, if you check, I have a new commit SHA1 here. So what I've done is, I made a commit. I realized I made a mistake. I brought the changes from the repository back to the staging index area, and then I made some changes and I committed it back to the local repository. This is reset soft head to the previous head. Okay. Now there's one more option you can do, when it's called the reset hard option, which will basically undo the previous commit itself and also discard the changes completely. Okay. Let's say I add some foo here. Since I've made the change, git status tell me that the authors file has been modified. And let me add this back. I'm from the working tree. I'm adding it to the index or staging area, and then I'm making a new commit. Now, if I do git log, it tells me there are 3 commits. Then I realized, this last commit was a mistake. There's no person called foo. What do? I want to totally remove this recent commit and also discard all the changes. Okay. So what you can do is you can do git reset hard, move head to the previous head. What this says is disregard my latest commit and move the head to the previous commit, and also disregard the changes that were made in this commit. Okay. So now head is pointing at, so initially head was pointing at this, and now head is pointing at this, right? So now if I do git log, there's only 2 commits here. And if I check ls and I do authors, only 1 name is there, right? So this is a case where we have made a commit to the local repository, and then we realized, oh, it was a complete mistake. We want to completely disregard the changes and the commit. So we do reset hard and move the head to the previous head. Okay. As you do commits, the head keeps moving forward. So these are the basic mechanics that people should know about between working tree, index, and repository. So I would suggest that you go through this presentation at your own pace so that you understand the actual commits and the workflow that happens here. The other useful commands like amend. So if you made a mistake in the commit message itself, you can do git commit -- amend. This is the hard example. So here we see that there's a second commit. I do hard, I remove the complete commit and also the change and the file, and we're back to square one. So the other useful commands that are useful with Git, you can grep for a specific pattern. You can search for specific tags, specific keywords using regular expressions. And then log has different options as well. So you want to see the history of your changes, last 3 days between specific tag releases, last 2 weeks, and so on. So these commands you can play around with. Stashing is very useful. Let's say that you are working on some specific feature request on your project, and suddenly a bug shows up, and you are asked to work on the bug immediately. So what do you do with your current changes in the working tree, right? So what you can do is you can stash away those changes. Let me show you the example. So here our repository is clean, and let's say I am just updating the README. I am putting the date here, right? And now if I check the status, I have some changes here, but then I have something else to work on this project immediately, and I can't just where do I save these changes? What you can do is you can do git stash, right? And if you, so those changes are saved somewhere, and currently it's saved somewhere. And if you want to like restore, you can just apply those stash changes back once you have finished working on whatever you are working with. So that's stash. So git stash list will tell you the one stash changes. So that you can have multiple stashes that you can store in the list. And then finally, if you want to restore this, you can just do stash apply. Now your changes are modified changes still there, right? So it's quite useful, especially when you're working on something and you have some bug or something that sort of interrupts your existing work. This is quite useful. Tagging is useful. So when you are making a release for your project source code, you will want to tag a specific version like 1.0, 2.0, 3.0, and so on. So for a specific commit, you can make a tag, and there are some, just use git tag. Sometimes you want to contribute to a project, you may not have git access, so you can create a patch. So git format patch is quite useful here. It contains the username, email address, the date, and list of changes, and you can just email it to the concerned people. These other commands, reflog, it has all your commit changes, so you can reset the repository at a specific commit. So all the changes are stored inside the .git folder. So anytime you can just reset your snapshot of your repository to a specific version. Let me talk about the branching concept. So by default, all your changes are in a master branch. Okay, so this branching is a logical concept. It's a very important concept to know, and it's a separate line of development that you can have on the same project. And let's say that I have so that's the typical workflow that you should use. Creating branches is very cheap, it's very fast, and hence learning to work in that stream is quite handy. Now, one important point I want to touch upon here is that whatever you're doing here is local, right? So for this git branch example, I will let you go through this. So it basically shows you, walks you through an example of git merge and then merging into the master branch. The other thing is there is something called local origin and you have remote origin, right? There's no remote added here. By default, you have a local origin. So there are a few questions that were asked by the participants in the initial survey. They asked about what is the difference between Git and GitHub. So Git is just a tool which allows you to sort of version control all of these projects that you have. It doesn't necessarily have to be software code. It can also be for documentation. Let's say you're writing a research paper and you want to version control the history of changes. You can use that. It's very good for text files, not good for binaries. And hence, you can use it for like project documentation as well. And GitHub is basically, or GitLab is a web front end that provides you a way for creating user accounts, and you can push your local changes to a remote repository. So you have local origin, then you have remote origin as well, right? And you can keep pulling changes from a remote repository to your local changes and so on. And it gives you a way of doing collaborative software development. This is Git. In the main master branch. Sometimes in a project, we don't really need to know all the small changes that you made. And we just need one single patch so that the commit messages in the master branch is very clean. So what we will ask the developers to do is do a rebase. Basically, you are replaying all your changes, maybe 10 to 20 changes, commits, to a single commit. Okay, and that's what rebase does. So this is an example here where so I'm making a commit. There are 3 commits in the master branch, and the latest commit is 19E0, whatever changes it has. And then, right, there's a separate branch I'm trying to pull from some user, and that branch has the latest commit as 1D, right? So I want to replay these changes to the master branch. So the way you do it is basically rewrite history, you rebase it with master. If there are conflicts, you have to manually go and make the changes. So you have a diff like this output. So you can choose whichever one is the correct text on either side of the equal to signs. And then you edit it. You can add it back from the working tree to the index, and then you just commit the changes. So I will let you go through these steps at your own pace so that you understand the actual steps involved here. As I was saying, there is local origin and remote origin. So if you have added a remote repository from GitHub, then you will make sure that you are pushing the changes to the right remote repository. So this is one example. GitOS was bought by GitLab. So here what I'm doing is I'm adding another developer's repository. Okay, so now I have my remote origin and the developer's origin. I'm doing git fetch. I'm fetching the changes from the developer. Now I see my branches. I'm checking what is the difference between my master and the developer's master. I'm checking out the changes from his new branch. I'm creating a new branch with his changes. I'm resetting it to a specific commit for the review. I'm checking out to my master, and I'm merging his master changes onto my master. This is a simple workflow about how to pull from remote and fetch the changes and do a commit. Right. So that's the gist of what I had overall, and I'm happy to take questions. Thank you.
Thank you, Mr. Kannan, for your overview presentation demonstration. There are a few questions. One is any project has got 5 elements, basically code, data, interface, documents, basically the instructions and documents, and also training. Does Git provide version control for all these items?
It's a good question. So Git is very good for text files. It's not that great for binary files. So like images or PDFs, and especially for large binary files, we generally don't commit it into Git. And one of the important things you should remember is that if you're cloning a Git repository remotely, and if you have like a large files in it, it might be very difficult to download them. So if you have some kind of test data that you want to use, generally we upload it into some CDN or some place, and then use a script to download it, and then you build it. So yeah, documentation, people, if they use something like text markdown, those can be revision controlled, or LaTeX. So if you're using that kind of documentation for your projects is good. But otherwise your other binary file formats, you can store them, but they'll increase the file size.
अरे नीलेश जोशी लिखेला वो.
I hope that answers the question.
Okay. This is OS dependent.
No, you can use Git on different operating systems. It's just a user tool. There are front ends. Editors also have plugins to use Git. The reason I teach this command line is so that people really understand the plumbing mechanics, how you move from working tree to staging index and repository, and how you should move files back and forth as you work. That is, I mean, you don't have to use all the commands. You don't have to know all the commands. You just pick the commands that are suitable for your specific workflow. And different teams, based on their experience, they choose what the workflow is, and you can just follow that.
Is there a GUI interface available for Git?
Yes, most editors have a Git plugin, and you can just enable the plugin and start using it with that. The presentation is available on my site. You can just go to site, and there's a PDF here. You can just click on this PDF.
And Kannan, can you explain how to handle merge conflicts?
Yeah, so merge conflicts are mostly because there are some detail which Git doesn't know how to resolve. So those things, it is up to the developer to resolve those changes. As I've shown in that example, the Git is not like intelligent enough to make a decision on that, because it doesn't know what the content actually means. It doesn't know about semantics, right? So depending on the project, the developer or the user knows what the change that is relevant. So if there are like two people working on the same file, then you need to sit together and resolve that. So the way it differs from central version control system is that in CVS or Subversion for that matter, there are conflicts there as well. Even in Git there are conflicts, but then you still get to work on the repository on your system, your laptop or computer, without really worrying about what other people are doing. And when you need to merge, only those merge level conflicts need to be resolved. So it doesn't stop you from working on cloning or forking any project and working on it. So yeah.
What are lost commits and how to recover?
So the most recent commits are shown in this example here. So this was the most recent commit here, right? And I don't know if I have git-k installed here. I can install this. So you should be able to see it graphically as well. So what do you mean by recover?
That is the commits, if it doesn't happen. So there are two people, there are some commits, if it doesn't happen, or maybe when two people are simultaneously committing, one may fail, right? So
No, that doesn't happen actually. So the way it works is, so basically you commit your changes locally and you push to your remote copy of the repository. So each developer has their own copy of the repository, and it's the maintainers, right? So what you need to do is you need to send a pull request or a merge request from your copy of the remote repository to the project, right? And then it's the maintainers of the project who will accept or deny the pull request. So you don't have direct access to the main project repository.
okay.
So let me give you an example. So this is an example of git-k. So quick visualization, it will tell you like what changes, what commit, and so on. But editors do have that. So if you take, let me go back to my GitLab account, for example. Right. So if you take this Operation Blue Moon project, which I help people to plan their work and so on. So what you see here is you see a lot of commits here, and where are the folks? Right. So here on the right, you see that 18 people have forked this project. So what it means is they have forked this copy of the project into their respective repositories, right? And that is their remote repository. And they will clone their remote repository to their local repository. So when they push changes, they always push to their remote repository. And when they want to send those changes to my repository, they will send me a patch pull request or a merge request. So in this project, if you see, there are 6 merge requests currently, right? So this basically allows people to like plan their tasks and so on. So what happens here is that, let's take Akshay for example. What has he done here? This is his copy, his remote repository. He's made a change, and he's asking me to merge his changes into my master copy of the repository. So there is no real conflict. If there's a conflict between mine and his version, then we need to sit together and talk and see which goes in where and then merge it. But as an individual, Git doesn't like stop you from forking a project and working on it. I hope that makes sense.
Okay. What is the significance of log files in Git?
Log files as in like the data files, or
No,
I'm not sure what the
basically,
question is.
no. Basically, whenever some changes are made, so are there any log files are maintained in the repository for the?
It's I think you need to check on the implementation for the content addressable file format, what it does, and it's that will give you more details on the implementation. Log files. It's not like your. I think okay. I see what the question is coming from. I think it's something like what you do in MySQL replication logs. It's not like that. It basically you have every change has some object and meta information. If you need more details, just look at content addressable file storage. I think that should give you the details.
Okay.
Questions though.
Yeah. And then see, when companies use the many of the software developing companies, they use the GitHub, right? Git
Right.
for their version control.
Right.
I mean, all these the version control repositories are locally maintained, right? They don't have to use the GitHub or something. Is it a mandatory, or it can be locally implementable?
Yeah. So if you want to set up your own Git server,
Yeah.
you can actually deploy. This is GitLab. I think they have a community edition. I'm not sure. So they have an enterprise version and a community edition. I don't know what is the current status of this. Might want to check. So this have a web interface and so on.
Okay.
There's also another option called Gitolite. This was written by one Sitaram Chamarthi, who works in TCS Hyderabad. So you can host your own version of GitHub, or it's just there is a UI also if you want to use, but you don't need it, and you can set up a local repository. This gives you more fine-grained control. You can give user level permissions, read-write permissions, and so on. So it's a different workflow. He's got a good book also. I would recommend reading that book if you want to use Gitolite.
So, which means that most of the people either they have to use the GitHub or GitLab or some facility,
Correct.
right?
Correct.
Right.
That's correct.
So, this what is the significance of Microsoft buying GitHub? How does it? Will they be having control over the?
I think that's a question to be answered by Microsoft. I don't think I'm the right person to answer that.
No, basically, when see every project, the information is going to be stored, or at least the people want to use this facility. So, does it mean that control is going to be with the owner of the facility, or
So
the developers will they lose?
So I mean, if you want to have like full control of your repositories, I think you can just set up a local version of GitLab. I think they have a community edition, or use Gitolite.
Okay.
So I think, let me just quickly check here. I think they have installed GitLab. They bought this company called Gitorious. So yeah, they have for different OSs. You can run it on Kubernetes as well. I mean, just check this. I haven't tried it, but
Okay. How popular this Git when compared to other version control systems?
right. I think today, if you're looking for a job in the industry, or you want to, whatever work that you're doing, I think having a repository, a Git repository with all your contributions are quite useful, and adding it to the resume is also quite useful, and hence it's completely transformed the way people do software development. Although it was initially written for the Linux kernel development, a lot of the projects have started using it, and it's very common, and it's important to have understand these latest tools that are there, and also have an account where you can showcase to people and for prospective employees to see what you have done. So it has made a lot of drastic change in the way we do software development.
Will the testing community have control over these versions? Basically, can they trace back what are the changes they have done?
So there is something called a git blame. So that will sort of tell you like which commit. There's also something called git bisect. You might want to look into that, where you can sort of bisect a series of commits into half and say whether that commit is good or a bad commit. And then you can take, just as you do binary search, you can take a set of commits and you can keep labeling them as good, bad, and identify which is a commit that actually caused a specific issue. So the command that you want to use with Git is git bisect and then git blame. Those will tell you like who made the commit as well. So that will be useful.
Okay. For agile development, Git is recommended, or so what type of how it is useful for agile development process?
So agile is just a process, and you can use any tools with it, because Git is fast and it's quite it's quite useful in doing productive work. People use that as part of the DevOps pipeline and the whole agile workflow. So yeah, I think there are two different things. It's a process. This is a tool. So,
Okay. So thank you, Mr. Shakthi Kannan, for your wonderful presentation. But anyhow, so this is new for many people. They are trying to.
yeah. So
learn.
yeah, thanks for the opportunity. What I would like to suggest is just
Basically, we just wanted some sort of, if we can provide us some reference material, we would like to inform our participants, so when we send the video recording of this talk, so we'd like to provide the references if we can give.
sure.
That would be
There's
great.
also a Git SCM book, and so there's a lot of material available online, and but try to practice at your own pace. That would really help, even if you like not understood everything. Work on the examples at your own pace, and I think you'll learn the mechanics of Git and start using it in your daily workflow.
Okay. Thank you.
Thank you for the opportunity.
Shaktivel, I request Dr. Shaktivel to formally propose the vote of thanks. Shaktivel?
Yes, sir. Good evening, sir. Good evening. On behalf of the Computer Society of India, Chennai chapter, IEEE Computer Society Madras chapter, ACM Chennai professional chapter, we would like to thank today's speaker, Mr. Shakthi Kannan, for his wonderful and hands-on lecture on Git, a free and open source distributed version control system. And on this occasion, I would like to thank Mr. H.R. Mohan, Chairman, ACM Chennai chapter, Mr. P.V. Subramaniam, Chairman, CSI Chennai chapter, and Dr. Ahila, Managing Committee member, CSI Chennai chapter, for their support in organizing this program. And I would like to thank all the participants who have eagerly participated in this program. Thank you, Ananda. Thank you very much, sir. Thank you, sir.
Okay. So before we formally close our meeting, I have a few announcements regarding our programs on 24th and 24th and 31st. We have programs on social media and NLP. On 31st, we have a program on DevOps. We have already sent invitations to our group, and we will also be sending reminders. So please register to these programs and attend them. Thank you. And with this, we would like to close our today's session. Once again, I would like to thank Mr. Shakthi Kannan for his wonderful presentation. And we look forward to your continued support to our CSI, ACM, and IEEE CS members. Thank you. Thank you, Mr. Kannan.
Thank you. And yeah, I look forward to more sessions with you. Take care.
Thank you.
Thank you, Mr. Kannan.
Thank you. Thank you.